If we draw a quick region, we'll see that the shading on the particle has no volumetric effect to it. I'm still using a surface shader, the scene material, Phong, and we're picking up some of the indirect illumination, some of the bounced light from the ground and from the sky. What we need is a volumetric shader, and in exercise 7, the new, what were previously known as the BA shaders, have made their way into the render tree list of presets. If I switch the ice tree temporarily over to a render tree, we'll notice that the particles menu now has a whole host of new shaders, and the ones that we're going to be using allow us to control the density of a volumetric effect and then shape the edges and the patterns within that effect. And we can do this using 2 or 3 nodes. It's really quite simple. To fix this problem here, let's go into the material manager first. Let's just get rid of this render region and assign a material, a unique material to this point cloud. So I'll just jump in. We're currently using the scene material. We can actually see that who uses the cloud point cloud does. So let's give our point cloud a new material. So I'll create a new material. It's kind of a throwaway material, so it doesn't matter what I use. I'll rename this cloud material, and I'll assign it to the point cloud. So my point cloud is selected. The cloud material, I right-click over top of it and assign to selection. So when I say who uses now, our point cloud is assigned this one material. I'm just going to pop open the little preset hide show tab. So I have access to all of my render tree presets as little drag and drop icons. And I really want to replace this Lambert with a particle volume shader. So if I open up the cloud material, we have the volume shader input as opposed to the surface shader input. And the first thing I'm going to connect is my particle renderer. So the particle renderer outputs a volumetric effect, and if I double click on it, we can see that it controls some of the main key effects of a volumetric cloud. In other words, density, the fall off within the cloud, linear or cubic, the shape, how blended or how coagulated the particles are, and then a global control for density. Controls for the particle color, whether we want them per particle color or per cloud or gradient. And tinting things like the ambience, the diffuse, and even adding ambient occlusion to the cloud if we need to. There's also some volume rendering clouds that allow you to set the detail of the cloud. How much detail do you want in these clouds? At a distance you might want to dial it down, and close up you might want to use some high quality settings, as well as the cell size of the cloud itself. If you have too small of a cell size, you don't have enough information to describe the volumetric cloud, and XSI visually will let you know that the cell size is too small, and we'll show you this in just a moment here. So I'm going to plug the particle renderer into the volume input of the cloud material, and we don't have any way of viewing the result of this particle renderer, so I'm just going to have to go in and draw a render region. And the first thing we notice is we can actually see a little bit of a cloud pattern appearing here, although that could also be the overlap of the spheres. But we also see it highlighted in red, and this is telling us that the cell size is too low. This is usually the first area, the shadow table you're creating, that you want to set up when you're working with a particle system, a cloud system. So I'm going to start increasing the cell size, and if I increase it to a size of 3, we start to lose the cloud error that is thrown for us. So there's a threshold you can reach, and the idea is to choose one that balances render time versus the look you're after.